Alright, so we're on to 6.4, day 2, continue with the properties of logarithmic functions. So, this looks like a whole big old mess, but the main thing we want to pay attention to is going to be this right here. Alright, the exponential logarithmic inverse properties. Now, what that basically tells us is when you see like a repeating number with the logs, like log base 7 of 7, or log base, so something like this, log base, let's say here 3 of 3 raised to the x, we know that this part right here, the log base 3 of 3, that's going to go away. Alright, so we're going to cancel that out, and we're just going to be left with the x. Okay? Same as if we were to have, let's say, 4 raised to the log base 4 of x. What happens to the log, or 4 raised to the log base 4, is that also goes away, and we're left with just the x. Alright? So to see this in action, we look over here, and we see that the log base, or 7 raised to the log base 7 of 9, well, the 7 raised to the log base 7 cancels, and we're just left with 9. And then we know that log base 2 of 16 is 4, because 2 raised to the 4th power gives me 16. This is something you need to know, be able to do without a calculator. You would be on your non-calculated portion of your test. You could see a problem like this on the non-calculated portion of the test. You will not have a calculator for that portion of the test because it's non-calculator. Okay, moving on. So let's apply that. So if we go through, I want to show you one of them, and then you can try the other ones. You can pause it. I'll go through all 4 of them, but feel free to pause and try it on your own. So for this first one, the 3 raised to the log base 3 of 9, that cancels. We're just left with 9. Plus, and I know log base 5 of 25 is 2 because 5 squared is 25, and that gives me 11. So pause it. Try number 2. And now we're going to go through number 2. So we have 2 raised, or sorry, log base 2 of 32. I know that's 5 because 2 raised to the 5th power gives me 32. Plus, and then this is 7 raised to the log base 7 is going to cancel, and I'm just left with that little 4 there. Hopefully it's not too hard to read. And we're left with 9. Sorry, this should be 11. I forgot to write the other one. All right, number 3. We have log base 7 of 49. So that's going to be 2 because 7 squared is 49. And then we have log base 5 of 5 raised to the 3rd power. Well, the log base 5 of 5 cancels. I'm left with 3. So I end up with 5 for my answer. This last one's a little bit trickier. Feel free to try it on your own. Pause it. And I'll go through it. So the 9 raised to the log base 9 cancels. I'm left with 2. Here's the tricky one. Log base 4 of 1/4. Now, if I had log base 4 of 4, I know that would be 1 because 4 raised to the 1st power gives me 4. But if I want 1 over 4, well, 4 raised to what power would give me 1 over 4? That's going to be negative 1. All right, 4 raised to the 1st gives me 4. 4 raised to the negative 1st gives me 1 over 4. So I'm going to have minus a negative 1. So that becomes plus a positive, which is 3. All right, next property, one-to-one property of logarithms. Now, this property is pretty darn simple except for some of the problems that are associated with it. So, with this problem, I know that if I have the same base, so log base b, that those logs are going to cancel out, and I can just have the x equaling the y, shown here. So the same thing goes with this example. My log base 3's cancel, and I'm just left with what was here in the parentheses. Now that I see this step here, I have an x squared. I know that I need to set everything equal to 0, factor, and solve, or use square roots to solve depending on the situation, or quadratic formula if we want. Well, this one is factorable. When I see x squared plus x minus 6, I know I can factor that. We're using this AM method, the x method, however you want to think about it. Multiply to negative 6, add to 1, so I get negative 2 and positive 3, which is why I have my factors right here, x minus 2, x plus 3. Now, my answers are going to be 2 and negative 3. However, with logs, you are not allowed to take the log of a negative number. Feel free to try it in your calculator. You could type in log of negative, let's say, 10. You plug that in, you're going to get an error message. Even if you did log of, say, -2, you're going to get an error message. They will not work. All right? So what I have to do is I have to check and make sure my solutions work, make sure that they're positive. So when I plug 2 in, let's say I plug into this first one here, I'm going to get 2 squared, which is 4, plus 2, or 7 times 2, which is 14. So we're up at 18 now, minus 5. That gives me 13. That's positive. That's good. If I plug 2 into this one, I get 12 plus 1, which is 13 as well. Now if I plug in the, so that one works. This is good to go. If I plug in -3, well, right here, if I can see right now that's going to be 6 times -3, which is -18 plus 1, that's -17. That will not work. I only need to check it now that it doesn't work. In that 1, I know it's not going to work at all. So -3 is an extraneous solution. 2 is our actual solution, which is why it says the only solution is 2. Moving on. All right, we're going to try one of these. How about we try one we did not do in class today? Why don't we try number 3 down here? So let's do that one. And maybe we'll try number 1 too if we have time. So for number 3 here, a little bit different. I'm going to put 1 log on each side. So I have log base 10 of 5x minus 3 equals log base 10 of x squared plus 1. Well, my log base 10s can cancel, and I'm just left with 5x minus 3 equals x squared plus 1. So I'm going to get everything on one side. I'm going to have x squared minus 5x plus 4 equals 0. I can factor this into x minus 4, x minus 1, because I know that -4 times -1 gives me 4, and -4 plus -1 gives me -5. So my answers are going to be x equals 4 and x equals 1. Now let's see if both of those work. If I plug them in, when I plug it into this one here, both 4 and 1 give me positive numbers. Both 4 and 1 over here also give me positive numbers. Both of these solutions are good to go. All right, let's continue. For number 4 down here, actually, let's try this one. This one looks a little bit tricky. So I'm going to move that 2, and I'm going to have log base a of x squared plus log base a of 2 equals log base a of 5x plus 3. Now, I noticed one thing over here. I have 2 logs. Well, I want to have 1 log on each side. It's the one-to-one property, so one thing on each side. However, I can condense this down to 1 log on the left-hand side with something that we've already learned earlier. So, let's take a look. What I'm going to do is I'm going to have log base a, and I'm going to multiply these, so 2x squared equals log base a of 5x plus 3. So from here I'm going to cancel these out. So I'm going to cancel out the log a and the log a, and I'm left with 2x squared equals 5x plus 3. Now I'm going to factor and solve. So well, first I got to set it equal to 0, excuse me. So I'm going to have 2x squared minus 5x minus 3 equals 0. And I'm going to be doing rainbow method on this one. Rainbow method. So my setup is going to be 2 times -3, 2 times -3, which gives me -6. And then I want to add still to -5. So my two numbers are going to be -6 and +1. So when I rewrite this, I'm going to move keep moving this down. Oop, there we go. What I'm going to do is write 2x squared minus 6x plus 1x minus 3 equals 0. Group them. Pull out my GCF, which is 2x. And now I have 2x plus 1 and x minus 3, and that equals 0. Not quite done yet. I got to solve each one. So, for this one here, I'm going to have 2x plus 1 equals 0. So I'm going to get negative 1/2. And here I'm going to get x equals 3. So let's look back at that original problem. This one's really easy to tell. If I plug it in to this one with an x right here, well, I can't plug a negative 1/2 in because then I'm taking the log of a negative number. Therefore, we have an issue, and I'm going to have to discard this one. All right. And then for 3, if I plug 3 in, it works in the first one. It works in this one here as well. So 3 is going to work. So 3 is my solution. So the main thing to remember with these guys is the one-to-one property is pretty darn easy, but it's the factoring that we involve with it that's the tough part. So if you're getting the fact that we need to cancel these two out, and then we have these two equal to each other, you're in pretty good shape. The tougher part is the factoring. Obviously, this one was very, very difficult with the rainbow method. You won't see too many of those, but you will see problems, especially like this for the number 3 right here, where it's just a regular reverse FOIL problem. Okay, so you will see something like this right here on a test, possibly. Okay. All right. So your homework is a worksheet on this one. We did a worksheet. It was a 6.4 worksheet. It says 6.4 up top. It is labeled on the website accordingly to being 6.4 day 2. You're supposed to do problems 1 through 15 all, and then 17 to 29 odd. All right.